My name is Feng Chen, and I am a PhD student at the Department of Civil and Architectural Engineering at KTH. My research topic is about the future of smart road solutions, with an emphasis of the infrastructure aspect. In the future, the physical roads will not only serve for the mobility of the vehicles, but may also be capable of enabling some other new functions that cater to future innovations in our road transportation sector. These new functions include such as intelligent communication, energy harvesting, on-the-road charging, and autonomous driving. From the infrastructure perspective, the integration of innovative smart functionalities into the existing road infrastructure can be very promising. It would also enable many new developments regarding more advanced road structures and materials, which are currently not feasible, considering limitations with respect to costs. Presently, I'm working on addressing the practical issues of the roads become smart or multifunctional, with respect to the demand for such as optimizing the structure design, improving the quality of the infrastructure materials, potential changes of the construction and maintenance principles, life cycle economic and environmental performances. These new demands will require continuous innovation in our road transportation sector, which will actually promote the sustainable development of this field and ultimately benefit our common society. In my PhD study, the on-the-road charging technology and automated road transport has been given my focus, and I would like to give some more detailed explanations as follows. Often referred to as electrified roads or e-roads, the on-the-road charging infrastructure can serve as an ordinary road while delivering electricity to the electric vehicles at the same time. This technology will significantly reduce the battery dependence of electric vehicles, decreasing thus the high initial cost and the range anxiety of using them. Specifically, I'm working on the infrastructure aspect of applying this technology. For instances, the study on such as the resistance to reflective cracking, rotting, and fatigue damages can help us understand the long-term service performance of this kind of complex road structure. The study on the electric properties of the road materials will help us assess the potential influences to the charging system, for instance, the energy transfer efficiency. And the study over environmental impacts will help us reflect on the real effectiveness of using this kind of infrastructure to improve the performance of the electric vehicles from a holistic point of view. Another smart road solution that I'm working on is the automated transport road. We know that autonomous vehicles have received great attention in recent decades because the potential benefits are so many, including such as reduced driver stress, reduced costs from taxi and commercial transport, increased safety, increased road capacity, and fuel efficiency. However, some of them may be overestimated due to lack of thinking from a holistic point of view. My interest is to have an investigation of the potential effects to the practical infrastructure by the use of autonomous vehicles at a large scale. For instance, the steering control of autonomous vehicles can be perceived as more accurate than that of the normal vehicles. This entails that the lateral wander of the wheels in transverse direction will reduce, and we have found that this will increase rotting damage potential when compared to that of the normal vehicles, leading thus to the increased economic and environmental costs for maintenance and rehabilitation actions. Finally, I want to conclude that this is just a brief introduction of my research at KTH, and please feel free to contact me if you have any further interest on the topic. Thank you.